Hello students. So today we are going to see continue the lecture on this chapter. So now we are going to look at in what order we'll be transmitting the bits and eventually the bytes. The motivation is this. So for example, if you have to send say an integer 167, we know in binary we could represent them like this, right? So in increasing exponents of 2, and then these are the actual bits that will form 167. So now if I want to send 167 on a channel, right, which order I would send, in the sense that would I send this one first or this one first? So what I wanted to decide is whether to send, this is the least significant bit. Why? Because its weight or value is just 1, whereas this one is valued 128. So that's how we call, which is the least significant and most significant bit. So this is the most significant bit, and this is the least significant bit. So now we wanted to decide which order we will send. Now it turns out that we could send in either order, depending on again whether the sender and receiver agree on what order the bits are being sent and received. Okay, so accordingly we can have two kinds of transmissions. If we send the least significant bit first, then it's called a little endian transmission. So always try to remember L in the little endian goes with this L, the least significant bit. And if we send the most significant bit first, then it will be called the big endian transmission. So in our example, if we send this least significant bit first, this bit first, which means if I send this bit first, so little endian transmission, if I send that bit first, the sequence of bits sent would be what? 1 followed by, or you can put it like this, 1 1, then 0 0 1 0 1. This will be the order it will be sending. And if you do big endian transmission, which means we'll be sending what? The most significant bit first, then we'll be sending as it is, I have here, right? So this is what we're going to talk about. Now the same thing could be extended to sending bytes. So for example, if we have a sequence of bytes that we want to send, for example, it could be a character array or a word or anything like that. We'll see an example later. So let's say we have a sequence of bytes or integers, even integers that form like 32 bits, right? So integers are normally represented in computers in 32 bits, which is 4 bytes. So if you have a sequence of bytes that need to be sent representing a particular data unit, again, which order you will send it. So in a byte, we will be able to identify, as we'll do in this example, which is the most significant byte and which is the least significant byte. So if, as in this example, this is the most significant byte and this is the least significant byte, right? So if we send the most significant byte first, okay, then it is called a big endian transmission. So same thing, most significant byte first we call big endian transmission. Okay, so it's up to us to refer to this B as either a bit or a byte. Okay, so then if we send the least significant byte first, then we can call it as a little endian transmission. Right. So now again within a byte we will have to decide whether to send the most significant bit or least significant bit first. So as in this example, we can send the bytes in the big endian order and the bits in the little endian order. Alright, so if this is the most significant byte, then byte 1 is the most significant byte, we'll send that first. Now within this byte, which bit will send first, that depends whether the bits are transmitted in the little endian or big endian order. So if we send the bits, if we transmit the bits in the little endian order, then this will be the least significant bit. So we'll send this first, followed by this, and so on, and this is the most significant bit. So given a sequence of bytes, you could indicate in this order in exam which one you will send first. So you have 32 bits totally broken into 4 bytes. So we'll send the most significant bit first, byte first, the least significant byte as the last byte, and we will send within a byte, again like you see here, within a byte the least significant bit is sent first, and then we will go in this order and send the most significant bit. Right, so let's take up this example. I have a word ant and I want to send this. Now in a word, you should know that the first character in the word is each character is a byte. So let's take up each character as a byte and we'll represent using the ASCII value of these characters. So the ASCII values of these characters, A is 65, N is 78, T is 84. So again we have those characters. Now the first character is always the most significant character or the most significant byte, and the last character is the least significant character or the least significant byte. Okay, so I can write byte A, right, as the ASCII value 65. So this is what it is in binary, and 78 is what in binary, and 84 is what is in binary. So now we want to decide how to send them. So I have to specify what is the transmission order. So if I say the bytes are sent in the little endian order and the bits are sent in the big endian order, which means the byte is little endian, which means what? Between these 3 bytes, which is the byte L, again L goes with least significant byte, right? So I should send the least significant byte first. So T is sent first. So as you see here, T is sent first. Now within this byte, which bit will be sent first? We'll be sending the bits in big endian order, which means the most significant bit will be sent first. Always L will goes with L, so the other way, big endian, the big guy goes first. The big guy is the most significant bit. So this bit, the most significant bit, is sent first. So in this order, 1 to 8. Then in this byte, we'll send again from the most significant to the least significant bit, and again from the most significant to the least significant bit. Right? So now again the same word, if you want to send the bytes in big endian and the bits in little endian order, the byte big endian, which means the most significant byte, which is A, is sent first, and within a byte the bits are sent in little endian order, which means the least significant bit will be sent first. So within this byte the least significant bit is this one, which one? I'm sorry, this is sent first, and from the least significant bit to the most significant bit. Similarly, for within this byte, from the least significant to the most significant bit, and within this byte from the least significant to the most significant bits, and so on. Okay. And now, in terms of just this is small thing that I wanted to say. We will come across in a networking terminology as part of it 3 types of transmissions: simplex, full loop. So this is what is all about transmission order. So this is a kind of a small divergence. So in terms of transmission direction. Alright, so we can call things as simplex, full duplex, and half duplex. So what is simplex? Simplex means transmitting data in only one direction at any point of time. So if you have sending from A to B all the time and not from B to A, then it's called simplex. Now if you could send from A to B or from B to A at any time, but only in one direction at any point of time, then we call it as half duplex. Then if we can send from A to B as well as from B to A at any time, then we can call it as full duplex. Okay, that's what it is. So as it's seen in the arrow, you can send for half duplex in both directions, but at any time only in one direction. Whereas in full duplex, you can send and receive in both directions at the same time. Okay, so we'll stop with this. So this is the end of this chapter sequence.